Morning, good morning, good morning. I hope everyone is happy and healthy and doing well. Let's get down to the lesson. So today we're talking about similar polygons, and in fact the standard says that we are going to be using similar and congruent triangles to solve real-world and mathematical problems involving the sides, the perimeters, and the areas. Okay, that makes sense. So if we're going to determine if they're, so what we're going to have you do is first determine if they're similar. You're going to have to find a scale factor. You're going to have to then solve problems that involve the sides, the perimeters, and the areas. So let's talk about the vocabulary very quickly and see if we can get down to some brass tacks. So when we're talking about corresponding sides and corresponding angles, we are talking about the sides and the angles that match up on two shapes of different sizes. Two shapes of different sizes. Now, this is easy when we are talking about drawings that are oriented the same way. So if you have got two triangles that are oriented the same way, that are in the same position, it's easy to make sure that the sides match up or that the angles match up. The problem comes when they don't match up, and you have to figure out what the corresponding sides or angles are when they're either turned around or you're not given a picture. So there's a really easy way of doing that. When they say similar polygons, they're going to simply say that, or what it means is that the angles are the same, the angles are congruent, but the sides are proportional, and the sides are proportional. So when they say that, you can actually just take the names. So let's say we've got triangle ABC and triangle DEF. Well, if you stack them on top of each other just like this, you can see that A and D match up. And in fact, A and D would match up. You can see that B and E match up. And you can see that C and F match up. But you can also see that the sides from the titles, not from images, from the titles, AB is going to match up with DE. And BC is going to match up with D or EF because of the position of their names. And so CA is going to match up with FD. Interesting, huh? Now, what is a scale factor? A scale factor is simply the ratio of how big or small you shrink, how much you shrink or enlarge a shape. But it's a ratio of the amount of shrinkage or enlargement. Between the two shapes. The scale factor is typically written as a fraction or a whole number, just as an FYI. All right, we're also going to be looking at a theorem today, 8.1, and basically it is saying that if there's a scale factor for their corresponding sides, it's equal to the scale factor for the perimeters. So basically we can use the exact same proportions for perimeter as we do for the sides. And that works out nicely when we're doing problems later on. Now, one piece that isn't written on here is, what about the area scale factor? So make sure you have this part written down. I mean, yes, everything should be written down. But the area scale factor in comparison to the other ones. So you're going to use the same scale factor. You're going to use the same ratio for the corresponding sides as you would for the perimeter. You're not going to use the same one for area. In fact, what you're going to do is square it. So if we double the size of a shape, if a square goes from being a 1 by 1 shape to being a 2 by 2 shape, the area, 1 times 1 is 1. 2 times 2 is not 2. The area is not also just simply doubled. It is squared. So, how are we going to find this? Well, we're going to take the scale factor of the sides or the scale factor of the perimeters, and you just square both the top and the bottom. Okay, so let's figure out how we write some similarity statements. That's where we are first starting is, well, how are we supposed to tell that they are? Well, first thing to know is that the angles are always congruent. So if we are given ABC is similar to DEF, the similarity statement is actually going to be that angle A is congruent to D, angle B is congruent to E, and C is congruent to F. You're basically rewriting the corresponding sides in a math sentence. Now, the sides are not congruent, they are proportional. So when we write the similarity statement, we cannot say that AB is congruent to DE, but we can say that it is similar to DE. And BC is not congruent, but it is similar to EF. And CA is similar to or proportional to FA. That's an easy way to write it, so you just have to remember you've got angles and you've got sides. Okay, so similarity statements for the figures below. You know, I could try and figure it out with the drawing, but you know what? It's just easier to stack them on top of each other. Stack the titles on top of each other. So the statement, we have to do angles and sides. So we've got G is congruent to what stacks up with it, T. R is congruent to F, and M is congruent to D. Then we match our, so that's part of the statement. The other one is side lengths. So GR is similar to FT. RM is similar to FD. And MG is similar to DT. And that's your similarity statement. Well, now that we know how to write a similarity statement, how do we know if they're similar? Well, the first thing we need to pay attention to is the way that our relationships are listed. So if you remember from last week, the units have to be the same. So this first one's super, super easy. But how would I do it if the units were all the same? Well, the easiest way is to simply write it as a fraction and reduce it. This can be reduced down to 1/5. Now, if you're not comfortable reducing fractions, use a calculator. Desmos will do it very quickly. But 6 also goes down to 1/5. And you can see that 1/5, guess what? That's our scale factor. All right, so 3/2 over 7/2 is going to be 3/7. 21/49 is also going to reduce down to 3/7. And this is going to be 1/3. So which ones are similar? The A and the B, because they have the same scale factor. Okay, so if they are similar, then we're going to simply write similar. If they're not similar, we're going to write not similar. If so, then we have to write the similarity statement. So remember, when we're looking for similarity, the angles are congruent, the sides are different. The angles are congruent, the sides are proportional. Angles congruent, sides proportional. Angles congruent. Those angles are not congruent. So this is not similar. Okay, angles congruent. Well, I can tell that A is congruent to N, R is congruent to T, and X is congruent to M. And then we have to determine if the side lengths are proportional or they are reduced down to the same ratio. So I'm going to do small over big. So we've got 6/9, which reduces down to 2/3. We have 10/15, which reduces down to 2/3. And we have 8/12, which also reduces down to 2/3. Oh wait, look. That's our scale factor. But this is not our similarity statement. Our similarity statement is MN is similar to XA, NT is similar to AR, and TM is similar to RX. So this, along with this, is our similarity statement. Okay, so to find the scale factor, remember we're going to stack the two sides on top of each other and reduce. So we have 3/2.4, and we have to use these measurements because these are the corresponding sides. This corresponds with this. Why couldn't we use 5? Well, we didn't know LM in order to determine its scale factor. Let's reduce this. So we're going to change our decimal, move our decimal over. This is 30/24. And 6 goes into both. 6 goes into 35 times. 6 goes into 24 4 times. So it says find the scale factor of RSTU to LMNO. So as we go from RSTU down to LMNO, is it getting bigger or is it getting smaller? It's getting smaller. So we start with big down to small. So if you notice, we've got 5/4, so it's going to be big over small. So what is the scale factor? It is 5/4. Now the scale factor going from LMNO to RSTU, well, we would put the 2.4 on the top and the RSTU on the bottom. And so our rate is going to be 4/5. Okay, find the side length of LM. Well, we're going to use, doesn't really matter which scale factor we're going to use. Let's use this one. So we've got 4 over 5. 4 is the smaller shape, and 5 is the larger shape. The 5 is on the larger shape, so it needs to go on the bottom. And we simply, 4 times 5 is 20, divided by 5 is 4. So what's the length? It is 4. You're going to set up and solve the proportion. Now, to find the perimeter of each polygon, we could use the same scale factor again after we found one of the perimeters. Well, I know because it's a parallelogram that 5 is equal and 3 is equal. So the perimeter is going to be 5 plus 5 plus 3 plus 3, that is going to be 16 of the larger shape. So let's say we use 4/5. Well, the perimeter of the larger one, that's the 5, is 16. That means the perimeter of the smaller one. And to solve this, we're going to do 4 times 16 divided by 5. 4 times 16 divided by 5. So 4 times 16 divided by 5 is 12.8. So the perimeter for this is 12.8. And the ratio of the perimeter of element NO to the perimeter of RSTU, well, the perimeter of element O is 12.8, and the perimeter of RSTU is 16. And if I put 12.8 over 16 into my scientific calculator, and I ask it to reduce it for me, because why not? It is 4/5. Oh, which is the exact same scale factor. Huh. Isn't that what this theorem was telling us? Absolutely. This is just a real world problem proving what this theorem is stating. All right. So remember, we have to focus on corresponding parts. So 6 corresponds to the 4. That becomes our first part of our proportion. And then we're always going to keep the sides matching. So if we're going to put X on the top, we would then have to put 6 on the bottom. For the other one, we're going to set up a separate proportion. We're going to put Y on the top. Ooh. Y on the top, and then we're going to put 8 on the bottom. And then solve these. 6 times 6 is 36, divided by 4 is 9. 6 times 8 is 48, divided by 4 is 12. Okay, so we have, it says the ratio of corresponding sides of ABC and DEF, so these are our ratios. So ABC is on top, DEF's on bottom, is 3 to 5. The perimeter of DEF is 48 inches. So is the 48 going to go on the top or on the bottom? It's going to go on the bottom because DEF is on the bottom. And you simply solve this. 3 times 48 divided by 5, which becomes 28.8. So something to keep in mind, as long as it's talking about the sides or the perimeter, you don't have to do anything to the scale factor. As long as it's talking about the sides or the perimeter, you don't have to do anything to the scale factor. Okay. The perimeter is 60, so we're going to put, oh, we've got a typo here, I apologize. E, F, G, H. So we've got A, B, C, D on the top, E, F, G, H on the bottom. We have 60 over 15. So it's asking us to find the scale factor. Well, I can reduce that, put it into a calculator. 60 over 15 is 4 over 1. So our first question is find the scale factor. What is the scale factor? 4 over 1. And the corresponding lengths of rectangle EFGH. Well, if ABCD is 18, 18 is going to go then on the top, because ABCD is on the top. X is going to go on the bottom because EFGH is on the bottom. So you're going to do 1 times 18 divided by 4. So the side lengths are going to be 4.5 centimeters. Now, what happens when it's talking about areas? If you remember, we're going to square the scale factor. So if the scale factor used to enlarge the triangle ABC was 1 over 4, we are going to square this, which means 1 squared is 1 and 4 squared is 16. So what is the scale factor that should be used when comparing the areas of the triangles? It is 1/16. So you have to pay attention. Are they asking you to find the scale factor for the areas? Are they asking you to apply it to perimeters and sides? Remember, when they're asking for areas, you have to square the scale factor for perimeters and sides. Okay, so we have ABC and GHI. So these are sides. So we can simplify these. 7 over 21. We can simplify this to 1 over 3. But then all of a sudden I see this really big word of area. This is the scale factor for the sides or for the perimeter. It's not the scale factor for the area. What do I have to remember to do? I have to remember to square it. So 1 squared. So to find the area square scale factor, 1 squared is 1 and 3 squared is 9. The area scale factor is 1/9. So again, ABC is still on top, GHI is on the bottom. It says the area of ABC, so 50 is going to go on top. Why? Because ABC is on top. So 50 times 9 is 450. So the area for triangle GHI is going to be 450 square inches. One last time. So we have side lengths. AB is 4 and GH is 10. We can reduce this to find the scale factor. That becomes 2 over 5. But now the question is looking at area. So we have to square the scale factor in order to find the area scale factor. So 2 squared is 4 and 5 squared is 25. This is the scale factor we can use for the area. Now the area of GHI is 50. So the 50, is it going to go on the top or on the bottom? It is going to go on the bottom. X is going on the top. 4 times 50 divided by 25. x is going to be equal to 8. So the area of triangle ABC is 8 inches squared. Okay, you should be able to determine if two shapes are similar. You should be able to write a similarity statement. You should be able to determine what the scale factor is between two similar shapes. You should be able to apply the scale factor to find perimeter or missing sides. And then you should be able to find the area scale factor and be able to find the areas of missing shapes.